Okay, here's part 2. This is just a heavy one. We're almost, well, I can't even say that. It's a heavy lesson. So it says find the equation of the inverse. So if you remember the rules from that first example, where I think it was y equals 5x plus 1 or something like that, here's the rules. Number 1, you're going to switch out your y's and your x's. So remember, this is actually y equals log 2x. So I'm trying to figure out the equation of this. And here's how you do it. We're going to switch the x's and y's. So x equals log 2y. That's step 1. Step 2, solve for y. Well, okay, how do I get y alone? Well, if I flip this thing around, my brain likes it this way. You don't have to. 2 to the x equals y. So 2 to the x equals y. And I think to myself, okay, wait a minute, I solved for y. Yeah, you did it. So now the last thing you have to do is replace it with this. And so we get 2 to the x equals, all right. And so there's the inverse function right there of this. So kind of interesting, more where that comes from. All right, another problem. It says find the inverse function of that crazy looking thing. First of all, I want you to know that you can type that into Desmos and you get something like this, just so you can have a visual image of what's going on. You're not going to have to do this on your homework, but I want you to kind of see what's going on. I'll be crazy. But, so, this is saying find the inverse function, which is this. But this problem's going to have a little trick to it, so pay attention. But let's stick with our rules. This is just the same thing as y. First thing we do to find the inverse function is we switch the x's and the y's. So x equals 10 to the y plus 1 power. And we're like, yuck, wait a minute. Now I have to solve for y? Yes, that's step 2 always. Well, where is y? It's up in the exponent. Remember our good friend the log? So we're going to slap a log on that side. We're going to slap a log on this side. Remember, this is now an exponent of a logarithm, so I can bring that into the front, and this is y plus 1 times the log of 10 equals the log of x. I know it's fancy looking, but we're just trying to solve for y. Log of 10, take your calculator, it's 1. This needs to jump out at you, get used to that. Anytime you see ln or log 10, both of those are just a nice, easy 1 every time. So be on the hunt for those. So this essentially disappears. So I have y plus 1 equals log of x. Subtract 1, subtract 1. I'm going to write it y equals log of x minus 1. But if I leave my answer right there, I got so close, but I screwed up. I forgot one step. This doesn't equal y because this equals y. So this is the inverse function. So I got to remember to replace this with what it really is. Now, if I said, hey, graph that. Well, you wouldn't have to go like this and fill out a bunch of x's and y's. You just say, okay, if this is the inverse function of that, and this graph is this, I would just have to flip it over. So it would look something like that. I hope that looks right. Okay. Throw that in for bonus. Now, if you ever get confused on graphing and you want to kind of double check your work, you notice I got this little point up here. What I did is I noticed this. If I put a -1 in for x, I get -1 plus 1 is 0. So 10 to the 0 would be 1. But x is -1. Y, wait a minute, that's not, never mind. Forget I said anything. This problem should be a breath of fresh air. This is based on your learning of transformations, but you got to know generally what does the graph of a logarithm look like. So the problem is graph this. And it looks like, whoa, that's out of my league. No, if you've been listening, what we've been saying is, and I want to make this point very clear, that point right there, for the parent function in the logarithms, you should always check out 1, 0 and think about it. So if I looked at this and I said, let x be 1, y be 0, and I'm going to turn it around so it looks like what we've been dealing with, and I'm going to ask myself the question, is this true or is this false? Well, 2 to the 0 power equals 1. Is that true or false? That's true. So this is a great anchor, a starting place for all parent functions, is this point right here. We'll always go through there, always. And remember, we said, generally speaking, it'll look like that. So get in the habit of that, but just know 1, 0 is your best friend. Okay? Go right through that, and then it's always your y-axis is your asymptote, and then it just goes slowly up and up and up and up. It just does. Okay? So the problem is asking, graph this. Well, I think the hard part's over, just knowing what the parent function looks like. But now this is just saying, hey, take that thing, bump it 3 units left. So I'm going to take this point, and I'm going to go 3 left. 1, 2, 3. Now notice, though, this portion of the graph continues to go to this direction 1 unit before it hits the asymptote, or tries to hit the asymptote. So I'm going to go 1 unit here. I'm going to copy this portion. That's the easy part. But then I have to know that this is trying to get to the asymptote, which is the y-axis. But that would be like an invisible line right here, and it would be like that. So that is simply bumped to the left. So if they asked you, hey, what is the asymptote of this whole thing? You'd go, that's x equals -4. The original's asymptote is x equals 0, or you could just say it's the y-axis, either way. So that one's not too bad. All right, so I threw a lot at you in that pre-lesson, 2 parts. Don't skip the example problems, because the example problems are where things are solidified, and it's less teaching, more doing, so you can kind of get a feel of what your homework's going to look like. That's why I do it.